Dear students, let's see the derivation of electric field due to an infinitely long straight wire. So first a diagram போடுவோம். ஒரு wire இருக்கு. It carries positive charge. So positive charge na it creates the electric field everywhere radially outwards. This negative charge now it creates the electric field radially inwards. What is actually the meaning of radially outwards inwards? In the பக்கம் at r distance the electric field is E. அதே r distance the electric field will be the same E only. So that is called radially outwards electric field. Radially it is same, electric field is same. இதனால தான் நம்ம என்ன பண்ண போறோம்னா Gaussian surface வந்து we are going to choose a cylindrical Gaussian surface. So it is a cylindrical symmetry, so we are going to choose the cylindrical Gaussian surface. இப்போ நம்மளோட aim என்னன்னா at some point P on the Gaussian surface which is at a distance r from the wire, what will be the electric field? That is our aim. We are going to find out what is the electric field at point P using Gauss law. So what is Gauss law? Gauss law can be written this way. The total electric flux enclosed by the Gaussian surface is equal to charge enclosed by the Gaussian surface divided by epsilon naught. Here, what is the charge enclosed by the Gaussian cylindrical surface? இங்க வந்து wire இருக்கு இல்லையா, அதனால நம்ம என்ன பண்ண போறோம்னா we are going to use linear charge density. What is linear charge density? Lambda equals the charge per unit length. So from here we are going to write Q as lambda times L. So let us write that here. Q is lambda times L divided by epsilon naught. So let's keep this as equation 1. இப்போ நம்ம flux என்னன்னு கண்டுபிடிச்சிட்டு and we are going to substitute it here. அங்கிருந்து நம்ம electric field கண்டுபிடிச்சிக்கலாம். So first let us draw this Gaussian surface. நம்ம Gaussian surfaceல cylindrical Gaussian surface னு சொல்லிட்டோம் சரியா. So இப்படி ஒரு cylinderல there are three surfaces. Okay, so the first one is the curved surface, second one is top circular surface and bottom circular surface. உள்ளர வந்து அந்த wire இருக்கு. ஓகேவா, charged wire. So it is all positive. Okay, now three surfaces are there in the Gaussian surface. இப்போ what will be the total flux through this Gaussian surface? We have to find out. So first curved surface la பாத்தீங்கன்னா suppose you take a small surface on the curved surface. இப்போ இது வந்து the outward normal இப்படி வரைஞ்சோம்னா this is the direction of the delta S surface 1 delta S1, and we know that electric field also radially outwards, so it is along this direction itself, so it is E vector direction. So we can write electric field E and delta S1, they both are actually parallel. So first we have done with the curved surface. Now we are going to do the same for the top surface. So let us take one small surface and its outward normal is delta S2. So it is in this direction. Now the electric field will be like this. So it is in this direction. This is electric field direction. So now if you see electric field E and delta S2, they both are perpendicular. And let's see here surface 3. Take a small surface area and then draw the outward normal. This will be like this, delta S3 vector. And we know the electric field goes here in this direction. So here also electric field is perpendicular to the small surface delta S3. Okay, now when we are calculating the flux through these small surfaces, the total flux is E dot delta S1 plus E dot delta S2 plus E dot delta S3. Now when we are expanding this, E delta S cos delta S1 cos, because they both are parallel, we are going to write this as cos 0 degree plus E delta S2 cos 90 degree because E is perpendicular to delta S2 plus E delta S3 cos once again 90 degree because delta S3 is also perpendicular to the electric field. இப்போ cos 0 லாம் உங்களுக்கு தெரியும். So cos 0 value is 1. Cos 90 is a 0. So cos 90 here also 0. So the term, second term and the third term will not contribute to the flux. So delta phi is actually equal to E delta S1. So this delta S1 is actually a small surface here. But if you consider the entire surface, the total flux through the curved surface of the cylinder is E times sum over delta S1. This is surface wise sum. So here this is actually the curved surface area of the cylinder. So what is the curved surface area of the cylinder? It is actually equal to 2 pi r L. So I think substitute பண்ண வேண்டியதான். So phi equals E into 2 pi r L. Okay, wow. Now this is equation 2. So the equation 1 is substitute பண்ண வேண்டியதான். So equation 1 என்ன எழுதினோ? Phi equals lambda L divided by epsilon naught. So we are going to substitute here phi as E 2 pi r L, which is equal to lambda L divided by epsilon naught. இப்போ நம்ம என்ன பண்ணணும்? L will get cancelled. So we can write E equals lambda divided by 2 pi r epsilon naught. So this is the electric field produced by the infinitely long wire, and we can write this in terms of vector notation, that is E equals lambda divided by 2 pi r epsilon naught r. Okay, usually we have to write the constants in front, and this is actually variable, so we can write this as n cap. N cap is the outward normal. That's it. Thank you.